hello everybody. Hello everybody. I hope you guys can hear this. Sorry. Oops, sorry again. It's like but it's fine. Yeah. So I guess we can go live right now, but we are still waiting for the rocket lab. So let's take it easy. And for now, there's not much else information we can know about this stuff, but it's okay. Yeah. And maybe in the meantime, I can try test with the transition. Maybe you guys can try see this. Okay. How is it? Is it good? I hope this is okay. Okay, so anyhow, we have live here. Rocket Lab has finally gone live with their introduction. So, without further ado, I'm going to say my word here. Okay, so visit word here. Okay, so I've already opened the music. So, ouch, ouch, ouch. Okay, so you guys should be able to hear this background. This one is literally from the Rocket Lab, so that's why. Okay, so I will properly introduce myself. Let's go in.
Good
So,
evening and welcome
hello
to the
everyone.
launch of our
Oh,
first Electron mission for
okay. So hello. So I'm going to go with the proper introduction. So let's go. So hello everybody. I'm Daniel Suguwa, your host today for the Rocket Lab launches that will carry the Open Cosmos 2 satellites. Not much else information we know, but what we know is that this is a low Earth orbit mobile satellite broadband mobile broadband satellite. Oh, what's my grammar here? Huh. And just for your information, not much else we know other than that. And also this is from what I know based on the on the Open Cosmos press release. They mentioned that Liechtenstein already gave them permission using the high priority carbon radio spectrum to actually uses the satellite itself. So yeah, let's go. So that's it. Let's go.
And to some extent is something good because it means that space data is already embedded
Yeah.
on the data
So
type
this is
of
the
all
information
of us.
we are learning. We are actually just learning. I and also the others of you guys are just learning it just as just what I'm doing right now, because there's
And that's
not much
ultimately the
information
goal,
we
right?
know.
That this information is just helping humanity across the world
Yeah.
continuously.
It's amazing what can be done with satellite data, whether it is extracting from imagery.
Yeah,
or
so this is
extracting
it.
from
You can go.
sensors on the ground.
Look at
which
this.
data gets collected by satellites. You can monitor climate. You can better understand the use of energy,
Mhm.
sustainable use of natural resources. All of these are challenges that can be addressed thanks to
Yeah.
this information.
The way we deliver this, we help achieve this data in orbit
Mhm.
is through three main products. One is open orbit.
Where we literally take
Okay.
care of the entire mission on behalf of the customer.
Is to design the satellite from scratch, manufacture it, test it, launch it,
Uh-huh.
and even operating it.
And the
Okay.
customer just gets the service that they
So
need,
this is
whether it
how
is
they
for
said,
navigation
and as you can see,
purposes,
there's a little bit like
telecommunication, or Earth
cube
observation.
set,
And
whatever
that's
is it,
what has
but
brought us to the point where
so
we
far
are,
what we
where
can
we
see,
are
this
one
is
of the
like their
leading
generic
companies in this
statement
field. We are delivering
so far.
missions as a service to both institutional and commercial
I guess this
customers.
is okay.
The second
Should be.
product is called the Open Constellation. And
All
that's
right.
a constellation where we mutualize satellites
And
from
yeah, this
different
stream
partners.
is literally
So rather than
direct from
having to pay
the
for a huge
from Rocket Lab.
constellation,
So
each one of them, they can share
so
the
you're
data
just
between
watching this
ourselves
as
and others
myself
to lower the
did.
cost.
It provides multi-sensor.
If I remember correctly,
variety
this one
of
is
data
Leo
that then
PND, if
can
I
be
remember.
used to derive
Leo
insights and
Pathfinder,
information
whatever
on the
is it?
ground.
The name is it?
And
Yeah.
the product is Data Cosmos. And Data Cosmos is basically a platform where we gather, harmonize diverse types of data sets. We
Okay.
enable the analysis of those data sets with third-party analytical tools from some of our brilliant partners in AI and so on around the globe.
By having this
Oh
data
my goodness.
enables people, companies, and organizations and be able to take
Yeah,
action. So
using
that's why
that
it's called
word again.
actionable intelligence, is because it's intelligence, information that then you can take action on.
Uniting dedicated satellite missions,
Oh
open
no.
constellation shared infrastructure, data cosmos insights, and secure connectivity, we build satellites to understand
Mhm.
and connect the world.
Okay, so this is basically their generic statement here. That's what the Open Cosmos
We're thrilled to
company
be
as a whole
providing
actually
Open
does.
Cosmos with a ride to space today. And tonight's mission might be our 80th launch overall for Electron, but it is great to be getting started with a busy year of launches in 2026. Now, launch
And of course,
operations
this
have
is
been
their
going
first year,
smoothly so far today, and
the first
weather
launch
is
of
expected to remain
2026, of
clear
course,
all
of
the
the
way through
Electron
to T0.
rockets.
Electron's
Rocket.
looking
So
good,
here we go.
and our operators are ready to make their way through the final few milestones in the countdown to liftoff. In fact, as we approach T-minus 12 minutes on the clock, we are coming up on the go, no-go poll run by this
Oh,
mission's
so
launch director, Michael Pearson from Mission Control. Now, this is the
10
final
ATP,
assessment
but
on whether
it looks
all of
like
Electron's systems
like if
are
they're
go for launch
using
and that our operators are
using
happy
50
to
frames
proceed.
per second.
And we have operators
Wow,
stationed
it-
at the Mission
it's actually
Control
pretty
Center,
surprisingly
east of the
smooth.
screen, and at our Range Control Center
It looks
located
almost
at
50
the launch
frames
site.
for me.
So let's
Wow.
listen into both and check in on how we are tracking for launch.
Maybe I can try look at this stat of notes. Yeah, it's actually 30 frames, but the frame interpolation here looks like
LD on mission.
40
Proceeding
plus
with the go, no-go
50.
sequence.
Okay,
Stage.
Stages go.
Avionics.
okay, this is a go,
Avionics, let's
no
go.
go poll. Let's hear it.
GNC.
GNC is go.
VCon.
Pecan is go.
T1.
T1 is
Mhm.
go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
MET is go.
MM.
is go.
And LD sub.
LD sub is go.
Okay, so all system
Okay,
is
the
go.
no-go sequence is complete. We are T
Okay,
minus 11
and
minutes, 20
and
seconds,
now
and
everything is
counting.
go.
We're
Go for
terminal
flight.
Count auto sequence at T minus 10 minutes. From this time, the 3-word procedure is in effect.
All right, and now the range and also
There you
mission
have it.
control
That is
has already
confirmation from
declared
Mission
for
Control
go.
that all systems are healthy, and we will be proceeding with the remainder of the count. So that
Mhm.
T0 liftoff time remains 11:52 p.m. New Zealand local time, or 10:52
Okay,
a.m. GMT.
if I'm right, this
We have
should be a
2-hour launch
pet
window
A.
for today's mission, so if
Should
we
be.
need to stand down for any reason, we have a few backup opportunities
Okay,
over the next few days
and
as well. Now, today's mission is headed on a southern trajectory from Māhia along the coast of New
okay,
Zealand before it heads over
this is already well
Antarctica
known
and on its way to orbit for
information.
Open Cosmos.
If you're
And
reading
if you're
from the
new to
NASA
Rocket Lab
Spaceflight
launches,
Forum,
let's
it's pretty
introduce you
known.
to our Electron rocket launching today's mission. So standing there on the pad at 18 meters tall, Electron is our carbon composite rocket powered by
Yeah.
3D printed rocket engines. Now, the rocket comes in 2 stages, along with a kick stage platform at the top of the launch vehicle that is attached to the pair of Open Cosmos satellites for this mission.
All right, so this
There
is
they
how
are.
it looks
They're
like
nestled
inside
the fairing,
inside
and
it.
the next thing
Oh,
they see
and this is the
will be their new
reveal.
home in space.
Yeah.
Now, where you see a white band
So
across
hopefully,
the rocket below
hopefully
the
we
fairing
have the
is where
best
liquid
for
oxygen
these
is being
launches
loaded into Electron's
because it
second
looks
stage.
pretty interesting
The
there.
low temperature of that propellant is freezing moisture on the outside of the rocket. And you can see the same effect to Electron's first stage further down as LOX continues to flow there as well. Now, Electron's total vehicle mass with that full load of propellant is 13,000 kilograms at liftoff. At the bottom of
Alright.
that first stage are 9 Rutherford engines, each of them 3D printed and powered by batteries. Now, with individual capability of up to 5,600
Alright,
pounds
so
of
meanwhile,
thrust force at sea
I'll
level.
just put
Combined,
into
the 9 engines
here.
produce about 50,400 pounds of thrust force at liftoff. And we use a single space-optimized Rutherford engine for the second stage. And on the kick stage is another of our 3D printed rocket engines called the Curie. We use this propulsion system on the kick stage for orbit raising and lowering
I mean,
maneuvers,
don't worry
and
about
to
my
circularize
bookmark.
the kick stage for payload
Sometimes it's
deployment
weird, but
once we reach the mission's
typical niche
1,050
stuff. It's
kilometer
okay.
target altitude.
Checks
All
complete.
right.
Copy that.
Okay.
S-band to switch to high power for flight.
Okay. S-band already switched to full power flight. And let's see.
Stage LD mission.
LD stage.
Yeah, so I've already
Proceed with
confirmed it.
sequence
It's
60
Pet
stage
1A.
terminal checks.
Looks like it.
The stage terminal
Pet
checks are marked.
1A. All right. All right. So pretty short notice actually. Very short notice.
Stage 1 and stage 2
But
high
it's
voltage
fine.
batteries ready for flight.
So my guess is actually really correct. It's actually
Now, like I said earlier in the show,
LC1A,
tonight's
Launch
launch is our
Complex
80th
Pet
mission,
1A.
and
So
it is coming
I will
hot
update
off the back
it
of one of
later
our
after
busiest
this
years ever
stream.
since
So
Rocket Lab was founded
should be good.
almost 20 years ago. Now, we launched more times than we have ever done
All
before
right.
in a single year, with 21 launches across launch complexes 1 and 2,
So
both here in New Zealand and on the east coast of
all
Virginia.
right.
We also opened Launch Complex 3 there as well for our new
All
Mega
right.
rocket Neutron.
So
And
yeah, it should be good.
2026 is set to be another massive one in spacecraft missions built by Rocket Lab.
All
With
right.
our largest production contract secured just before Christmas with the Space Development Agency. As well as a
Yeah.
couple of Launch Plus spacecraft missions flying on Electron set for 2026 too. Now, while the countdown continues, here is a quick look back at what we got up to last year to set the
Okay,
scene for
T
the new year
minus
ahead.
7 minutes and mark. Okay, so we can look. This is the highlight
3, 2,
for the Rocket Lab in 2025. So let's see. Oh yeah, if I remember the LC3, yeah, Launch Complex 3, the Rocket Lab Launch Complex 3, located in the Mars, aka Mid-Atlantic Regional Spaceport. That one is in Virginia, US. The same, if I remember, it's just next to the Wallops flight facility, if I remember correctly. Yeah, so that's actually pretty interesting. Okay. And that launch pad that they showed you, the Launch Complex 3, that one, if I remember correctly, it's actually oh, why? It didn't detect mine. Ooh. Okay, I guess bad lighting. Oh, hold on. Let me come. Let me come to the rescue for the lighting. So. Alright, this should help. Sorry for that. You might see my avatar suddenly didn't move. Okay, that's a bad lighting. I'm very sorry. But now we are still coming in. As you can see, soft deflight, including from what I can see, this could be also the HEST flight as well. HEST is basically like the suborbital version of Electron rockets. So yeah, so basically Electron rocket is pretty versatile. It can either be the orbital one, which typically we know the Electron as it is, or it can also be or it also can be a suborbital sounding rocket as well. With this one, you know, the HEST rocket. If I remember, HEST actually stands for high altitude suborbital test evaluation. If I remember correctly, that's that what actually HEST stands
Now,
for.
back to
Yeah.
the countdown. And
So
like I
yeah,
said earlier in the show,
that's
tonight's
one of
launch
the interesting
is
stuff.
our 80th mission, and we have just 4 minutes or so left to go until liftoff. So what will happen next is that we will turn to the launch auto sequence that comes in at around T minus 2 minutes. That's when Electron's
Okay.
flight computer takes over autonomously and runs through those final milestones all the way through to liftoff.
All right.
Then
So
at around
looking at
1.5
this one,
minutes
considering
into the
the launch
sequence, we will
itself,
start to hear some of those final
we
calls
might
as we
actually
get close
see
to final
we might actually
pressurization
see
of those tanks as well.
that
And
this
then it's
mission
up
will
to
go for the
the
telemetry
mission
up
control
until
director to then
deployment,
announce
because
the
they already
T-minus
show how these
10
satellites
seconds
looks like.
countdown
So
to liftoff,
we might
and then
we
launch
might have a
Open
very
Cosmos
good
to
luck
space.
here.
So with
So
3
let's
minutes
see.
50 seconds left on the clock to get us there, let's hand it over to mission control and listen into those final counts.
Yeah, so that's a very interesting stuff you need to see there. All right. Okay, so like she said in the announcement, she said that at T minus 2 minutes, this Electron rocket will actually go into the automatic flight sequence where all of the internal computer and also the flight data recorder and instrumentation will also be powered on automatically for the preparation going into the flight, and of course it's also for whatever automation in behind the
All
scene
stations
for the
LD
flight.
on mission. From now, there should be no red flags on your critical LCCs.
All
Decon
right,
LD mission.
should not be
LD
any.
decon.
Please
All
select
right,
auto sequence and confirm.
all right,
Confirm all flight computer
all
ASCOs
right.
are
So
green.
we have already confirmed.
Confirmed.
Yeah.
Okay, all stations, we are go for auto sequence start at T minus
All
2
right.
minutes.
So
LD is go for launch.
okay, go for launch, and I'll do a little bit of screen calibration if you don't mind. Let me see if there's anything wrong there. Yeah, I guess. Yeah, I guess this is fine. Okay, it should be good, huh? Okay, get ready. T minus 2 minutes. Mark T minus 2 minutes. Going in for the
The
flight.
vehicle is fully on internal power.
Okay, fully in internal power and also on
ALTS is
the
green and enabled for flight.
automation mode. All right. All right. So that's it. We are getting ready for the flight. And of course, in case you hear something weird in the background, well, don't worry, that's not me. I'm not saying it. But if by chance
Looks
you
like
don't
the
hear
fuel system
anything,
is in recirculation.
you see a little bit of cut, you know why. Because I like to keep this channel family friendly. If I as the best as I can. So yeah. So and also looks like T minus 1 minute and 10 seconds, and getting ready for T minus 1 minute in before liftoff. Okay, and there's sequence already start. Mark T
Once you got
minus
through, just
1 minute. Okay, so getting ready in T minus 50
Stage 1 and
seconds.
2 tanks are pressed for flight.
Okay, so here we go.
high flow engine purge enabled.
T minus 40 seconds. And getting ready for the flight. T minus 30 seconds. I don't know why it opens. Okay, it's still fine. T minus
T minus
20,
seconds and
19,
counting.
18, 17, 16, 15, 14, 13, and this is electron mission control at T minus 10,
10,
9,
9,
8,
8,
7,
7,
6,
6,
5.
5, 4, 3, 2.
Okay,
1.
all 9 Rutherford rocket engines has already ignited and liftoff from New Zealand. Liftoff from the Māhia Peninsula from the Rocket Lab Launch Complex 1A. We have liftoff, carrying the two satellites of the Open Cosmos for the LEO, low Earth orbit mobile broadband satellite. So here's the missions go, and you can see it's ignite pretty well. All of these electron rocket, except the upper stage, is the Carolox propellant, liquid oxygen as the oxidizer, and RP1, rocket propellant 1, super refined kerosene as the fuel. As you can see in this flight is pretty good and should be getting ready for the supersonic or Mach 1 speed of sound. Okay, should be Mach 1
Approaching max Q.
and getting ready for the max Q, maximum aerodynamic pressure on the rocket itself.
Cleared max Q.
Alright, so it's already reaches the max Q. Maximum aerodynamic pressure fully exerted on the launch vehicle as the rocket velocity is going up at a certain atmospheric layer of point.
And up next will be
When these two meets together, it will create a very max pain region for the rocket itself that could that highly stresses and imparted the launch vehicle, aka the rocket mechanical, acoustic, and what's on, and also even the payload inside it. In this case, the satellites of the Open Cosmos, 2 satellites of it.
You'll be able to see
And
those 3 events happen in real
and
time
more
from
and
Electron's
from what I
cameras,
know is that
and
most
those
of these
callouts should be coming from mission
rocket
control
engines,
shortly too.
it's actually 3D printed and also battery powered, aka electric pump fed rocket. So instead of using turbo pump, it uses the DC motor, if I remember correctly, to spin it up and also to push the propellant down to the rocket, to the combustion chamber, and that's you can hear the main engine cut off, stage separation, and you can hear the vacuum sound. Not really vacuum sound, the sound of the rocket onboard sound there. We can hear for the separation and also the ignition of the second engines start of the vacuum version of the Rutherford. Only one Rutherford vacuum rocket engines there, and we are getting ready for the nose cone fairing shot. Fairing payload shots jettison, and we can see the jettison of it. And now finally the rockets has already and finally the satellites are now being exposed to the full brunt of the space itself, especially surrounding it. And also the nose cone, aka known as the payload fairing, aka also known as the payload shroud, finally no longer needed as it already passes to the 99% of the Earth's atmosphere's thickness there, no longer needed anymore, so it's already separated. And another thing that you need to know is that inside the fairing, usually it will be coated with the typically would be coated with a few with a good amount of thin aluminum sheets. It has a little bit like alloy in between of it, so it can absorb the acoustic. It can absorb the acoustic, the pressure and what's on, to keep the satellites safe and also to ensure it still can go for the flight. Alright, so right now the altitude is 206 kilometers, velocity is 10,600 kilometers per hour and counting up. Yeah, and as you can hear from the announcement, of course, you can hear that there, if I remember correctly, there is like 4 battery packs here, with 2 sets of it still, yeah.
When that switch
So
occurs, what you will see is the silver packs on your screen right now. They'll be jettisoned from the vehicle. And that's both our visual confirmation that the hot swap occurred, and we should also hear that call out from mission control at about the same time, which is around 6.5 minutes into the mission.
okay, and as you can hear from the announcement, you can see there's actually 4 battery packs here, So the two sets of it still being used, and two will be reserved and will be turned on at the same time when the used battery pack finally jettison out, and that's going to be it. We're going to see the battery hot swap jettison soon enough to keep the launch vehicle aka the rockets lightweight, and to ensure that the payload can be focused going out to the space, or technically to be more technical, to the correct orbit. So that's why the battery hot swap needed. Okay, slowing down a little bit, throttle down slightly, and getting ready for the battery hot pack jettison. Get ready for the hot swap. Okay, we have hot swap confirmation from the visual, and here we go. Here we go for this flight.
Nicely done. That is battery hot swap successful for Electron's second stage Rutherford engine, with no change to the vehicle's trajectory, as that second stage clocks more than 16,000 kilometers an hour, now more than 280 kilometers above Earth. And next up will be SECO, or second engine cutoff, which is the moment that engine will shut down to separate the kick stage into its nominal transfer orbit.
Yes.
Now, to reach the
So
1,050
that's why
kilometer orbit required for this mission, the kick stage is released at the mission's perigee, or the closest point to Earth in its trajectory, and then sent on an elliptical path to meet its apogee, the farthest point.
Yeah, so that's why you can hear. Oh yeah. Okay, should be correct right now. And as you can see from the hot glow of the rocket's engine itself, the reason why it glows orange, and also and also at the tail end of it with reddish color, is that because just like I said, it actually burns a super refined kerosene there, and you know that kerosene is actually a pretty complex hydrocarbon composed of carbon, hydrogen, no oxygen though. Yeah, it's only carbon and hydrogen, but there's like complicated chaining between of it. There's a lot of components inside it that when it burns this kind of color. And of course, because it's hydrocarbon, and because there's too much molecule there, sometimes it can be a little bit inefficient, inefficient from time to time. But however, it does compensate in terms of how good is it to be filled up, and also tremendous amount of energy going out from the rocket nozzle itself that can be used to finally propel into space and into the correct orbit.
Now, the next call we should hear from Mission Control is that guidance is terminal for the second stage before engine shutdown.
Okay, getting ready for the terminal guidance confirmation, and then later on we will hear the SECO, second engine cut off. Soon enough. Let's hear it. And by this time, okay, so SECO has already confirmed. Should be terminal guidance and should be kick stage separation. All right, kick stage separation looks already confirmed right now. So
and by what you saw on your screen.
yeah, so that's what you can hear right now.
Now that cutoff has occurred, and the kick stage is in its nominal transfer orbit as it heads towards that nominal target for this mission.
Transfer orbit.
Now that coast around the Earth will take around 55 minutes or so before the Curie engine on the kick stage lights up to course correct the orbit to a circular low Earth orbit. And we're going to take a break from the webcast while that happens, but we'll be back to follow along with the kick stage engine cutoff and payload separation at around T plus 1 hour, 7 minutes. We'll see you back here soon.
Okay, so here is it. There's not much else we can discuss because not enough information, and also, yeah, not enough information about the satellites, not even enough information about where's its final orbit and what's on. But however, we do know the launch has finally occurred, and it looks pretty good so far. And yeah, just like what she said, I will also going to take a little bit of rest and probably have myself some dinner for tonight. It's already as far as as far as I can tell, it's almost 7:04 p.m. here in Sarawak. Yeah, so I think it's a good time for me to also get a little bit of rest, and also getting myself ready for the next stream. So that's it, everybody. Thank you so much. I will also going to have a little bit of dinner for tonight. So yeah, I'll be back soon, as we are also going to see the payload deployment of the Open Cosmos 2 satellites there. So that's it. Thank you, everybody. I'll be back soon, and take care. We will see you soon after this break. Yeah.
Welcome back to our latest launch of Electron for the Cosmos Will See You Now mission for space company Open Cosmos. Now, this is our 80th Electron launch and first mission of the year that began with a nice, clean liftoff from Launch Complex 1 in New Zealand at 11:52 p.m. today. And after clearing through 9 minutes of flight, the pair of Open Cosmos satellites on Electron's kick stage were separated to a transfer orbit to deliver them to their 1,050-kilometer LEO altitude for this mission. Now, since that separation occurred along an elliptical trajectory, we ignited the Curie engine on the kick stage a few minutes ago to circularize the orbit. And what will happen then is that total engine burn for that course correction is around 4.5 minutes, which will actually be our longest Curie burn to date. Then the kick stage will reorient itself to deploy the satellites along their desired plane, and the 2 satellites for Open Cosmos will be released to their new home in space. So let's bring up the audio channel from Mission Control to listen in to the first of those callouts, Curie engine cutoff.
Curie cutoff confirmed.
A successful Curie engine shutdown for the kick stage there. Only a few more seconds to go now until it's in position to deploy the Open Cosmos satellites to orbit. Now, this animation here will depict that reorientation we mentioned before, and we should see a simulation of payload deployment along with confirmation from Mission Control. So let's listen in now.
Payload separation confirmed.
And there it is. Welcome to orbit for those pair of Open Cosmos satellites. That is payload deployment confirmed by Mission Control and mission success for Electron's 80th launch and first mission of 2026. What a great way to begin another busy year of launches. We've got a lot of amazing customers on the manifest this year, including, of course, Neutron's debut out of Launch Complex 3. And if 2026 is feeling a little bit new year, new you, why not check out the career section of our website? We are recruiting across almost all disciplines and roles, from rocket science to finance, and we'd love to hear from you. We've got our next mission scheduled in the coming days from Launch Complex 1, so keep an eye on Rocket Lab's Facebook, X, and Instagram pages for information on our next mission. Otherwise, thank you for joining us, and until next time, this is Rocket Lab Mission Control, signing off.
All right. All right. Very sorry. Very terribly sorry, everyone. Uh, I'm I'm going out way a lot than I like to, but as you can see, the deployment is successful. We can try look at it again at the replay. Okay, let's look again at the replay of the deployment. Okay.
Welcome back to our latest launch of Electron for the Cosmos Will
All
See You Now
right,
mission
so
for space company Open Cosmos. Now, this is our 80th Electron launch and first mission of the year that began with a nice, clean liftoff from
all
Launch
right.
Complex 1 in New
So
Zealand.
let's
at
look again
11:52
at the
p.m.
replay.
today. And after clearing through 9 minutes of flight, the pair of Open Cosmos satellites on Electron's kick stage were separated to a transfer orbit
All right.
to deliver
So
them
this is
to
what
their
happens a
1,050
few minutes ago,
altitude for
around
this mission.
2-3
Now, since that
minutes ago.
separation
So
occurred
let's
along
look
an
again.
elliptical trajectory, we ignited the Curie engine on the kick stage a few minutes ago to circularize the orbit. And
Okay,
what
so
will
this is how
happen
it looks.
then is that that total engine burn for that course correction is around 4.5 minutes, which will actually be our longest Curie burn to date. Then the kick stage will reorient itself to deploy the satellites along their desired plane, and the 2 satellites for Open Cosmos will be released to their new home in space. So let's bring up the audio channel from Mission Control to listen in to the first of those callouts, Curie engine cutoff.
Okay, so this is what happened a few minutes ago. Okay, oh, never mind. We don't have to skip. Let's just watch as it is.
Curie cutoff confirmed.
Okay, after that around 2 minutes plus ago, the Curie engine hyperstate
Successful Curie engine
upper stage
shutdown
cut
for
off,
the kick stage
and
there.
after that
Only a few more
short,
seconds to go
shortly
now until it's
followed
in
by the
position to
separation
deploy
of the
Open
satellites
Cosmos
itself.
satellites to orbit.
Let's see.
Now, this animation here will depict that reorientation we mentioned before, and we should see a
Okay, you can
simulation
see
of payload
that's how it
deployment along
reorients
with
itself,
confirmation
and
from
after
Mission
that it
Control.
separates
So let's listen in now.
in its direction. And looks like it's like, okay, it's hard to determine. Maybe 45 degrees, or maybe it's just like whatever. It's a bit hard to. Okay. Eventually, there is it. Oh, so there's like some sensitive payload. Because they actually blurred it out. Okay, that's very interesting. Very interesting.
And there it is. Welcome to orbit for those pair of Open Cosmos
Oh,
satellites.
okay, so
That
that's
is
how it's
payload
separated.
deployment
So
confirmed
it's
by Mission
separated,
Control,
it
and
reorients,
mission
and then after
success
that it's
for
separated
Electron's
going
80th launch
up
and first mission of
instead of going
2026.
down.
What a
Okay,
great way to
that's a
begin
very
another
interesting.
busy year of launches. We've got a lot of amazing customers on the manifest this year, including, of
Alright,
course,
so
Neutron's
that's all.
debut out of Launch Complex 3.
That's the
And
only
if
thing we need to know
2026
about the
is
replay.
feeling a little bit new year, new you, why not check out the career section of our website? We are recruiting across almost all disciplines and roles, from rocket
Yeah,
science
so
to
in case
finance, and we'd love to
you're
hear from
looking
you. We've got
for
our
work,
next
for job,
mission scheduled
for
in
career,
the coming
this is
days
what
from Launch
you want.
Complex 1, so keep an eye on Rocket Lab's Facebook, X, and Instagram pages for
Alright.
information on our next mission. Otherwise, thank you for joining us, and until next time, this is Rocket Lab Mission Control, signing off.
Okay, so that's it. That's the only thing you need to know. And looks like that's the launchpad view 2+ minutes ago. And that's it. That's the only thing you need to know. So yeah, sorry everybody, I didn't go back right in time. Well, I got a little bit of distracted, but it's okay. It happens to us. And at least I've already done my best. Okay, so yeah, so this is it. Okay, so yeah, everybody, I guess that's all. There's not much else I would like to talk right now. There's literally finish, and the only launch manifest that we have for today would be the NS-38, the New Shepard mission. This one is the suborbital crewed flight, yeah, but certainly, even though you can see this, even though I could technically even though I could technically go live, but the problem is that I do have some other kind of things in my way, so unfortunately I'm not be able to stream this one is literally midnight in my place. So, and that's not even counting variations of delays that could even take hours, that it might actually be not very good. It's going to be a very, very stressful countdown for me. So I'm not going to try to wait. I'm not going to try guess anything else. But however, I wish Blue Origin and its crew a good luck. That's all I can say here. And definitely things that I can actually try to go stream would be this one. I don't want to stream this anymore. We've already streamed this Starlink, so no need to stream anymore. Or I don't know, maybe I can stream this again, so I can compensate for this one, for something like this. Yeah, launches from the Cape Canaveral. I will be back. Possibly I will be back when I back again. If I can stream regularly, almost as regularly as I can. I will try to replace it with 2 other Starlink launches from Cape Canaveral. That's one thing I can tell you if I do stream this one. But however, if I don't, my stream replacement would be just only one on one Starlink launches from Cape Canaveral. That's all I can say. It's like 1 by 1, you know. So no, it's more like 1 to 1. Yeah, so that should be good. But definitely things that I can try stream would be the GPS3 SV09. Okay, this one. If I remember, the last replacement is SV10 or SV11, if I remember correctly, or SV12, whatever is it. Okay, and then after that, there's going to be an unknown payload, the Long March 7A. But however, because I already streamed this before, and even then there's a lot of stream I already did with Long March 7A. And also it's literally in the wee morning, so I don't think I can do this. Yeah, I don't want to do this 5 a.m. anymore. Oh, and also I wish I can stream this, but I don't know, man. I mean, seriously, I don't know. Can I try stream that? Wow. So Tuesday. Maybe. Okay, which means if I decided I try to go stream there I need to sleep very, very early, I guess. Yeah, I can try do that. But I don't know. I need to look at the manifest again. There will be a little bit stressful for me to try go stream around this time. Yeah, I mean, this is okay, but the problem is that it's very wee early in the morning, so I'm not pretty sure if I could even stream this. Yeah, I'm afraid I can't, but never say never, you know. I can sure try if I can. So yeah, I guess that's it. If there's no more any further streaming and whatnot, that's going to be the last one. So yeah, everybody, thank you so much for watching, and also for tuning in the first 10 minutes or so of the launches. And unfortunately I didn't get right in time at the end of the deployment, but I do compensate it with the replay. So so that's actually not really that far away. That should be good to go. And yeah, I'm going to end this stream with my trademark here. So this is Daniel Suguwa. I'm your host for today's launches of the Rocket Lab's Electron rocket that carries the 2 open cosmos satellites, aka the LEO, the low Earth orbit satellite LEO, low Earth orbit mobile broadband satellite. Okay, satellites, just to correct myself. And which basically, other than what do we know so far about it, has that carbon antennas payload capability. We don't know the rest of it. It could be dual purpose, it could be a dual use, you know, civilian and military. We don't know. There's not enough information here to say, but could be dual use. But other than that, I don't want to speculate any further. So thank you so much for watching, and yeah, if you do enjoy this stream and other of my stream, and maybe in the future, maybe if I can try make a little bit of video, because I got bored. Maybe I got myself too bored in the house. If I'm back again with my family, maybe I can go stream. I mean, sorry, not stream, not maybe making video, but don't expect that video is super duper high quality. Don't expect that that happens, but I'll try my best, not just so we are able to pass in pretty well with that. And yeah, and also surprisingly, there's not many people view here, but if you're one of the 10 total live stream viewers here. You are awesome, and I really love you guys. So thank you so much for watching, and take care. Bye bye, and see ya for next stream whenever is it, because rocket launch schedule can change from time to time. So that's all, everybody. Take care. Bye bye, and see ya. And yeah, that's it. Bye bye. And literally, there's nothing else behind the scene. What else you need to know? It's already finished. That's it. Take care, everybody, and take care of yourself. And seriously, go away, enjoy your day. Don't even try. Don't even go and try ledge too much on this stream. There's nothing to it, nothing else. I mean, not like I have anybody to talk right now. There's literally zero live stream viewers here as I'm talking right now. so basically everyone is already going out, and I'm happy, and you should too, because in the context of at least we are relieved, everything is ending pretty nice. So that's it, and yeah, see ya. Bye bye, take care. And yeah, hopefully I'm a little bit of playful with that kind of word. Don't take it too literally. Okay, so that's it. Bye bye.